This video is about sinusoidal graphs. These are graphs of sine functions or cosine functions and their various transformations. This is AP Precalculus topics 3.4 and 3.5. If you appreciate this content, please give it a like. If you have not already memorized these 9 trig values, pause the screen and memorize them right now. Every time I show you this chart, I'm going to assume I'm showing you something that you already know. Hopefully you also know that cosine of theta is equal to the x-coordinate and sine theta is equal to the y-coordinate on the unit circle, a circle centered at the origin with a radius of 1. In order to graph y equals sine theta, let's complete this table of values. The sine of pi over 6 is 1/2. Let's put 0.5. The sine of pi over 3 is radical 3 over 2. That's about 0.9. What about the sine of pi over 2? Well, pi over 2 is right here on the unit circle, and sine is the y value of this point. The coordinates of this point are 0, 1, so the sine is 1. Now we get to the sine of 2 pi over 3. The sine of 2 pi over 3 will be the same as the sine of pi over 3, which was 0.9, except it might be negative depending on the quadrant. This is pi right here. We can think of it as 3 pi over 3. That way we can easily see that 2 pi over 3 is going to be one multiple before 3 pi over 3. That is in the second quadrant. Sine is the y value, and y values are positive in the second quadrant. So we will keep it as positive 0.9. The sine of 5 pi over 6 will be the same as the sine of pi over 6, which is 0.5. Except, again, it might be negative depending on the quadrant. This time, let's think of pi as 6 pi over 6. Therefore, 5 pi over 6 will be one multiple before 6 pi over 6, so we are still in the second quadrant where y values are positive. We know that pi is right here, where the coordinates are -1, 0. Sine is the y value, which is 0. Now we get to the sine of 7 pi over 6. This will be the same as the sine of pi over 6, which is 0.5, except it might be negative depending on the quadrant. Pi can be thought of as 6 pi over 6. Therefore, 7 pi over 6 will be one multiple past this, which puts it in the third quadrant, where y values are negative. Therefore, sine will be negative 0.5. The sine of 4 pi over 3 will be the same as the sine of pi over 3, which is 0.9. Except it might be negative depending on the quadrant. This is 3 pi over 3, so 4 pi over 3 will be one multiple past this. So again, in the third quadrant, where y values are negative. So the sine will be negative 0.9. What about the sine of 3 pi over 2? Every quadrant has a measure of pi over 2 radians. So right here is 1 pi over 2, this is 2 pi over 2, and 3 pi over 2 is right here, where the coordinates are 0, -1. Sine is the y value on the unit circle, so the sine of 3 pi over 2 is -1. The sine of 5 pi over 3 will be the same as the sine of pi over 3, which is 0.9, except it might be negative depending on the quadrant. We can think of pi as 3 pi over 3, and we can think of 2 pi as 6 pi over 3. So we can see that 5 pi over 3 will be one multiple before 6 pi over 3, which places it in the fourth quadrant, where y values are negative. So the sine will be negative 0.9. The sine of 11 pi over 6 will be the same as the sine of pi over 6, which is 0.5. except it might be negative depending on the quadrant. We can think of pi as 6 pi over 6 and 2 pi as 12 pi over 6. So 11 pi over 6 will be one multiple before 12 pi over 6. So it's still in the fourth quadrant where y values are negative. So sine is negative 0.5. 2 pi takes us all the way around and back to the start, where the coordinates are 1, 0. And sine is the y value, so it will be 0. Now we can graph all of these points. Let's begin actually with the sine of 0, which will be the same as the sine of 2 pi. So the sine of 0 is 0. Next we have the sine of pi over 6, which is 0.5. Then we get to the sine of pi over 3, which is 0.9, so almost up to the 1. And the sine of pi over 2 was 1. And then the sine of 2 pi over 3 takes us back down to 0.9. The sine of 5 pi over 6 takes us back down to 0.5. And I'm just going to continue to graph the rest of these points. Once you plot all of these points, it makes a wave pattern like this. This is what one period of the graph of y equals sine x looks like. This is a very important parent function, and I want you to memorize the look of it. Notice that the period begins at 0, 0, and then it rises to its highest value of 1, falls back to the midline of 0, and then falls to its lowest value of negative 1, before rising back to the midline at 0. Here is some vocabulary you need to know. The midline of a sinusoidal function is halfway between the maximum value and the minimum value. For y equals sine x, the midline is y equals 0, the x-axis. The amplitude of a sinusoidal function will be the distance from the midline to the maximum value. This will be the same as the distance from the midline to the minimum value. Notice that for the sine function, the amplitude is 1. You already know that the period of a periodic function is the horizontal length of one cycle. For the sine function, that length is 2 pi. The frequency of a periodic function is the reciprocal of the period. Since the period of the sine function is 2 pi, the frequency will be 1 over 2 pi. A word about concavity. Looking at one period of the sine function, we see that half of the period is concave down, and half of the period is concave up. This pattern will repeat forever to the left and to the right as the sine function switches back and forth, or oscillates, between being concave down and concave up. Now let's graph cosine theta. As we do so, remember that cosine theta is equal to the x value on the unit circle. Let's start with the cosine of pi over 6. We know that cosine of pi over 6 is radical 3 over 2. When we were graphing the sine function, we found that the decimal approximation for the radical 3 over 2 is 0.9. And cosine of pi over 3 is 1/2. That's 0.5. Pi over 2 is right here on the unit circle, where the coordinates are 0, 1. On the unit circle, cosine is the x value, which is 0 at pi over 2. So the cosine of pi over 2 is 0. The cosine of 2 pi over 3 will be the same thing as the cosine of pi over 3, which is 0.5, except it might be negative depending on the quadrant. Pi can be thought of as 3 pi over 3, so 2 pi over 3 will be one multiple before 3 pi over 3. That places it in the second quadrant, where x values are negative. So the cosine of 2 pi over 3 is negative 0.5. The cosine of 5 pi over 6 will be the same as the cosine of pi over 6, which is 0.9. except it might be negative depending on the quadrant. We can think of pi as 6 pi over 6. Therefore, 5 pi over 6 will be one multiple before 6 pi over 6. That's still in the second quadrant where x values are negative. Pi is right here where the coordinates are -1, 0. On the unit circle, cosine is the x-coordinate, which is -1. So the cosine of pi is -1. The cosine of 7 pi over 6 will be the same as the cosine of pi over 6, which is 0.9, except it might be negative depending on the quadrant. 6 pi over 6 is right here, so 7 pi over 6 will be one multiple past that, and in the third quadrant, where x values are negative. So the cosine of 7 pi over 6 is -0.9. The cosine of 4 pi over 3 will be the same as the cosine of pi over 3, which is 0.5, except it might be negative depending on the quadrant. And 3 pi over 3 is right here, so 4 pi over 3 will be in the third quadrant, where x values are negative. So -0.5. Every quadrant is pi over 2 radians. So this is 1 pi over 2, 2 pi over 2, and 3 pi over 2. So down here at the bottom is where 3 pi over 2 radians is, and the coordinates of this point are 0, -1. And on the unit circle, the x value is cosine, and that is 0. The cosine of 5 pi over 3 will be the same as the cosine of pi over 3, which is 0.5, except it might be negative depending on the quadrant. We can think of pi as 3 pi over 3, and doubling that we can think of 2 pi as 6 pi over 3. So 5 pi over 3 will be one multiple before that in the fourth quadrant. X values, and thus cosine, are positive in the fourth quadrant. It's to the right of the y-axis. So we will leave the cosine as positive 0.5. The cosine of 11 pi over 6 will be the same as the cosine of pi over 6, which is 0.9, except it might be negative depending on the quadrant. We can think of 2 pi as 12 pi over 6. So we see that 11 pi over 6 will be one multiple before that in the fourth quadrant, where x values, and thus cosine, are positive. So we will leave it as positive 0.9. This position on the unit circle is considered 0 radians if we think of it as the starting point, and also 2 pi radians if we picture it as going all the way around and back again. Either way, the coordinates at this point are 1, 0, and cosine will be the x value on the unit circle, which is 1. So the cosine of 2 pi and 0 are both 1. So I'm going to actually start with the fact that the cosine of 0 is 1 as I begin this graph. So the cosine at 0 is 1. So we're starting up here at a value of 1. Let's graph a few of these points together. So the cosine of pi over 6 was 0.9. So that's going to be right here, just a little bit below. And then at pi over 3, the value was 0.5. Then we got to pi over 2, and we are at a value of 0. And then at 2 pi over 3, we dropped to -0.5. At 5 pi over 6, we're at -0.9. And then at pi, we're at -1. 7 pi over 6 brings us to -0.9. And 4 pi over 3 brings us back up to -0.5. At 3 pi over 2, we are at a value of 0. And then at 5 pi over 3, we rise to 0.5. 11 pi over 6 brings us to 0.9. And 2 pi brings us all the way back to 1. This is such an important parent function that I want you to memorize what the graph of cosine theta looks like. Memorize that it begins at its maximum value of 1. Then it begins to fall. It passes the midline, which is at 0, and then halfway through the period, it falls to its lowest value of -1 at pi. And then it rises back to the midline of 0, and finishing the period back at its maximum value of 1. Key features to focus on. Just like for the sine function, the midline is y equals 0, also known as the x-axis. Also, just like the sine function, the amplitude, the distance from the midline to a low or the midline to a high, is also 1. Again, like the sine function, one period of cosine has a length of 2 pi. Therefore, the frequency, which is just the reciprocal of the period, will again be 1 over 2 pi. And like the sine function, cosine switches back and forth or oscillates between being concave down and concave up. It will continue to oscillate back and forth forever in both directions. The graphs of sine and cosine are so similar that they are grouped into one category called sinusoidal functions. But in fact, in a way, they are not just similar, they are the same. I've graphed the sine function here in red, and cosine x is graphed in blue. However, I've given my cosine function a slider that will allow me to do a horizontal translation. So here I'm going to nudge it pi over 8 to the right. Now if I go another pi over 8, so that's pi over 4, and another pi over 8, so that's 3 pi over 8, and if I move it one more pi over 8 to the right, kabam! It looks just like the sine function. So you can think of the sine function as just a cosine function that has been translated pi over 2 units to the right, or you can think of the cosine function as just a sine function that's been translated to the left by pi over 2. To summarize, a sinusoidal function is any function that involves additive or multiplicative transformations of sine theta. The sine and cosine functions are both sinusoidal functions because cosine theta is equal to the sine of theta plus pi over 2. In other words, the cosine function is just the sine function after a horizontal translation by negative pi over 2. Example 1. Two periods of the sinusoidal function f of theta are shown in the figure above. Find the period, frequency, amplitude, and midline for the graph of f at theta. The period is the length of one cycle of the function, and this period goes from 0 to pi, so the period is pi. The frequency is just the reciprocal of the period, so that will be 1 over pi. The midline is the line halfway between the highest point and the lowest point. This is the line y equals 3. A horizontal line is always y equals something. The amplitude is the distance between the midline and the highest point. From 3 to 6, that's a distance of 3 units, so the amplitude is 3. Notice that the amplitude is always positive, because even if we go from the midline to the lowest point, the distance is still 3. Let's do the same thing for example 2. The period is the length of one cycle, and here's a cycle that goes from 0 to pi over 2. So the period is pi over 2. Let me mention that you can use any cycle to calculate the period, but if you don't start from 0, then you have to subtract. This cycle goes from pi over 2 to pi. Therefore, the period will be the bigger number minus the smaller number. That's pi minus pi over 2. To make like denominators, let's think of pi as 2 pi over 2. And 2 pi over 2 minus 1 pi over 2 is 1 pi over 2. So we get the same thing using any cycle. The frequency is the reciprocal of the period. So flipping this upside down, we get 2 over pi for the frequency. Time for the midline, which will be halfway between the highs and the lows. From 3 to -1, that's a total distance of 4 units. So halfway will be 2 units down, and here we are at the midline of y equals 1. The amplitude is the distance from the midline to the highest value. This is a distance of 2 units, so the amplitude is 2. Example 3. The sinusoidal function h of theta has a maximum at the point pi, 8. The first minimum after reaching this maximum value occurs at the point 3 pi, -2. Find the period, frequency, amplitude, and midline for the graph of h of theta. I recommend sketching a graph where each mark is 1/4 of the period. So we are told that h of theta has a maximum at the point pi, 8. So I'm just going to pick one of these marks and call it pi. So this is pi right here. And the maximum is at 8. So I'm going to use this mark for the maximum value. Let's call it 8. By the way, this is not the x-axis. This is just the midline. It could be any number. So here's my first point of the sinusoidal function h of x. If each one of these marks is 1/4 of the period, then the graph will fall to the midline at the next mark. At the next mark, it will fall to its lowest value, and then it will rise back to the midline, and then end up back at its highest value. One period of h of theta looks like this. Now, back to the description. The first minimum after reaching the maximum occurs at 3 pi, -2. So we're talking about this point right here. This is the first minimum after reaching the maximum. So this must be the point 3 pi, so that's the input value, -2. That is the output value. So this must be -2 right here. This is enough information to answer all of these questions. Notice that the horizontal distance between the high point and the low point is exactly half of the total period. In fact, this comes up all the time, so add this to your notes and memorize it. From max to min, or from min to max, is always half the period. In this case, half the period is 3 pi minus pi, which is 2 pi. If half the period is 2 pi, then multiplying both sides by 2, the full period must be 4 pi. And since the frequency is just the reciprocal of the period, that will be 1 over 4 pi. The midline is the horizontal line halfway between the high and the low. From 8 to -2, that's a distance of 10. That means half of this distance must be 5. So if I do 8 and then -5, that leaves me at 3. So the midline is y equals 3. Double check this. We're saying 3 is in the middle. 3 plus 5 is 8. 3 minus 5 is -2. So that makes sense. Ha! We accidentally calculated the amplitude as well. The amplitude is the distance from the midline to the max value. So the amplitude is 5. There will be 4 free response questions on the AP exam. This problem is modeled after FRQ number 3. This is important enough that I want to give it its own video. So watch the next video to see FRQ number 3 Model S. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.